In this video, I shall be discussing about chemical effects of electric current and electrolysis. So the first one is chemical effects of electric current. When electric current is allowed to pass through a substance, it can affect the chemical composition of that substance. Therefore, the phenomenon of chemical changes occurring in a substance when electric current is allowed to pass through that substance is called chemical effects of electric current. Okay, now when electric current is allowed to pass through, okay, various types of chemical effects can produce. So what are they? Let us see. The first one is when electric current is allowed to pass through the substance, there will be decomposition of the substance into its constituent particles. Okay, the next one is if electric current is allowed to pass through the substance, there may be change in color of a substance. Okay, the color of the substance may change. Okay, and the last one is if electric current is allowed to pass through that that substance, then evolution of gas may take place. Okay, the next one is electrolysis. The decomposition of a chemical compound into its constituents due to passage of electric current through it is called electrolysis. Let us see one example. When electric current is passed through water, okay, and in the water it is mixed with little hydrochloric acid. Okay, so when electric current is passed through that mixture, then it decomposes to produce hydrogen gas and oxygen gas. Okay, so that hydrogen gas and oxygen gas will be released in the atmosphere, okay, because it is a gas. Then the electrolysis involves the passing of electric current through the electrolyte. Okay, an electrolyte is a solution. Okay, now the electric current is passed through the solution with the help of two electrodes, and those two electrodes are called cathode and anode. Okay, so you can see the construction here. This is the solution and that is known as the electrolyte. Okay, so suppose this electrode is called the cathode. Okay, cathode, as I said, it is connected to negative terminal of the battery. Okay, and anode, okay, anode, this two can be of same size. Okay, so it's connected to the positive terminal of the battery. Clear? Like this. The next one is the electrolytic cell. So electrolysis of a substance is usually carried out in an apparatus called the electrolytic cell. So this is the diagram of the electrolytic cell. Okay, so it contains the container which is made up of glass or metal. It contains the electrolyte. Okay, it is a solution. Okay, then it is also a mixture. Okay, then two electrolytes, one is cathode, the other one is anode, battery, and a switch is present. Now when the device is switched on, okay, when it is turned on, then electric current will pass through the electrodes. Okay, so electric current will pass through the electrodes and then it will go into the electrolyte. Okay, so the electric current will pass through the electrolyte. Okay, then when the electric current passes through the electrolyte, okay, the molecules of the electrolyte, they get broken apart into ions. Okay, so whatever molecules are present in this electrolyte, because of the passage of the electric current, the molecules will break into ions. Okay, ions are, one is called the cation and the other one is anion. Okay, anions are negative, cations are positive. Okay, then the positive ions, okay, they get attracted towards the cathode. Okay, plus and minus like charges, unlike charges, they attract. Okay, so that's why the positive ions, which are called the cations, they will get attracted to the cathode, and the negative ions will get attracted to the anode. okay, and that way the ions undergo further chemical reactions, okay, on reacting with the electrodes. Then the chemical changes in an electrolytic cell occur around the electrodes. So see, once the cation and anion will go to the two electrodes, okay, respectively, a chemical change, okay, will occur, that is around this region only, okay. Then the kind of chemical reactions that will occur and the kind of substance that will form will depend on the nature of the electrolyte as well as the electrodes, okay. Now let us take one example. Suppose the electrolyte contains water and sodium chloride, okay. The water will dissociate into H plus and OH minus, hydrogen ion and hydroxide ion. NaCl will dissociate into sodium ion and chloride ion, okay. Now here the chloride ion is negatively charged particle, therefore it will get attracted to anode, positive, okay, minus plus, and H plus will get attracted to cathode, okay, which is having negative. So plus minus and minus and plus, okay, unlike charges attract, isn't it? Then this OH minus and Na plus, they remain in the solution, they remain here, and this Na plus, okay, Na plus and OH minus, they mix together to give NaOH, okay. So see, the hydrogen ion that get attracted to the cathode and the chloride ion that get attracted to the anode electrode, okay. So what happens is the hydrogen and chlorine bubbles stick to the cathode and anode respectively, okay. I'll give you a task to solve, okay. So I want you to go through the other two topics, which are electroplating and electrorefining.